Okay, hello. This is just a quick reply to a student who's emailed me with this question. It's a parametric equation question, and what they wanted you to do, this is the equation, I've just quickly drawn it up on GeoGebra, and what they wanted you to do was essentially find the points where the gradient is infinite on the curve, which is here and here, and then the points where the gradient is 0 on the curve, which is here and here, yeah, or something like that. That seemed to me what the question was basically about. So obviously we need the gradient function, so we're going to implicitly differentiate, and we get 2x minus, product rule here. Think of it as differentiate the 2x, you get a 2, times it by the other side undifferentiated, then differentiate the y, we get a dy by dx, times it by the other side undifferentiated. But because you differentiate a function of y, you've got to stick a dy by dx on the end. Same here, you're going to get 6y dy by dx. I don't think this was what was confusing you though, because you hadn't written any questions about that anyway. But we're going to find a gradient function because I'm going to talk about it. It's an interesting question. Okay, so what do we get? We get 2x minus 2y minus 2x dy by dx plus 6y dy by dx equals 0. And factorising that, or actually should we just add that to that side? So we've got 2 times x minus y equals, and now we should have just halved everything to be honest with you, but never mind. And then we're going to get dy by dx is, we're going to get 2x minus 6y, and therefore put that underneath, we'll get 2 times x minus y equal over 2 times by x minus 3y equals dy by dx. And you cancel the 2's and you get the answer. Yeah, so that's the gradient function. Now, what can we use that for? Well, the gradient function will tell you where the gradient takes certain values. Now, finding where the point is northernmost is pretty easy actually, because or southernmost. If we want to find, let's call these, I think they called these P and Q. Can't remember which way around it was. Let's call this R and S. Yeah. So both R and S are where the gradient is 0. Yeah. Now if the gradient is 0, then I'm going to write 0 equals x minus y over x minus 3y. I'm going to times that over there, but 0 is like a big sort of like, you know, it's a black hole, isn't it? When you times by 0, you just end up with 0. It just swallows everything like that. And so that will occur on the line y equals x. And sure enough, look at this, at 5, 5, it looks like it's definitely occurring. It might not be exactly on 5, but S and R definitely look like they lie on the line y equals x. So the next thing you need to do is plug y equals x into here, and so you're going to get x squared minus 2x squared, because y is x, so that's 2x times x, so 2x squared plus 3x squared equals 50, and so that's 2x squared equals 50, and so x squared is 25, and so x is 5 or minus 5. I don't think the question actually required you to do that, but sure enough, we did get 5 and minus 5 for R and S. Yeah, wow. Now, what about when the gradient is infinite? Oh dear, how do we handle infinity? Yeah, because you can't really key into dy by dx. You can't really replace dy by dx with infinity, can you? Like, you know, what does it even mean to say infinity equals x minus y over x minus 3y? Well, let me tell you. Mathematicians would always say that infinity is not like a number, and it isn't. It's true, it's not a number, it's a concept. It's the idea of things getting bigger and bigger and bigger. They can increase without limit. But very loosely speaking, a fraction is equal to infinity when the denominator is 0. Yeah. Now, how can I justify that? Well, I'm going to justify it with limits. I'm going to say if you've got a over b, yeah, and I'm going to say a doesn't equal 0 to make things simpler. I can say the limit of a over b as b tends to 0 equals infinity, yeah? And we do loads of work with limits actually as mathematicians, we really do. Now this is kind of like, this is definitely okay for mathematicians to say. What it means is, well, let's just look at it like this. What's 6 divided by 0.1? 60. What's 6 divided by 0.01? 600. What's 6 divided by 0.001? 6,000. In other words, as the denominator gets closer and closer and closer to 0, the value of the fraction gets larger and larger and larger. Hence, if you want to find where the gradient is infinite, don't write infinity equals x minus y over x minus 3y. Simply just point out dy by dx tends to infinity as x minus 3y tends to 0. You don't have to write that down in the exam. All they want you to know in the exam is this is where the denominator equals 0. And so that's why we get x minus 3y equals 0 in that part, and we do x equals 3y, and then you just follow the working. But I hope that makes sense. If you've ever got to find an infinite gradient, and the gradient is a rational function, by which I mean written as a fraction, some kind of rational expression of some algebra divided by some other algebra, if you've got to find where the gradient is infinite there, make the denominator equal 0. If you've got to find where the gradient's 0 though, make the numerator equal 0. And that's why we make the numerator equal 0 for when the gradient is 0, and the denominator equals 0 for when the gradient is infinite. Hope that makes sense. All the best and keep up the hard work. Bye bye.